So before I jump into the second part, where there's some algebra that we need to review, and that algebra is called completing the square. You do it in intermediate algebra, you do it in college algebra prep. Let me just do two quick problems to refresh your memory on something you might have forgotten. In intermediate algebra, I write problems like this, and my instructions are replace the c with a number so that the expression becomes a perfect square. Then factor the expression. This we have to be good at, otherwise the next problems are bad. This isn't particularly hard. So how do I do this? I need to find a number for c, so easy to do. C, the number I'm going to replace it with, is the number in front of the first power term, in this case an 8, divided by 2, and then squared. So c, we usually say it's half the middle term squared. Might say it's b over 2 because this is a b in the quadratic formula. In this case, my c is going to be 16. So first thing I'm asked to do is replace c with a number. So I'm going to replace the c with the number 16. And now I'm going to factor this. It's always the case when you're using this process to pick a c that this is going to factor into a perfect square, meaning you get two identical parentheses. When I go to factor this, I'm going to split my x squared up among the firsts, and then after my x's, that's what I'm going to fill up, and I call it my lasts. My lasts need to multiply to 16, and they need to add to 8 because the number there at the end is 16 and the 8 is the middle term. And that's so easy. 4 times 4 is 16. 4 plus 4 is 8. It's always the case when we're doing completing the square that the parentheses factor into two identical parentheses so that I could write them with an exponent of 2. One more trick that we're going to get in this section, usually we say a double negative can be turned into a positive. I'm going to do the reverse. A positive can be turned into a double negative. When I'm graphing circles or writing equations for circles, I really like to have minuses for my signs. I don't like to have pluses, and a double negative is the same as a plus. So I've met my requirements here. I've taken this problem and I've replaced the c with the number 16. I factored the expression into x plus 4 squared, and then I wrote it something that's going to be more suitable for when I'm factoring circles, when I'm working with circles. Let me do another one of these. Let me give you x squared minus 6x plus c. I'm going to do the same for this. I'm going to replace c with a number so that the expression becomes a perfect square. How do I find c? C is always found by forming a fraction that has the coefficient of the first power term in the numerator and 2 in the denominator. Some of us say half the middle term squared. So we form that fraction, divide, and then square. In this case, c is going to be negative 3 squared. Negative 3 squared is negative 3 times negative 3, which is 9. So for this expression, if I want to replace the c with a number, the number I'm going to replace it with is 9. Done with the first part. I'll replace the c with a number. Now I'm going to factor the expression. How is it going to factor? Well, I'm going to get 2 parentheses. They're going to lead off with x's to satisfy the x squared. And the numbers at the end, they need to be double minus, because in order to multiply to a positive 9 and add to a negative 6, you need double negatives, because 2 negatives will multiply to a positive and add to a negative. So I need 2 negative numbers that simultaneously multiply to 9 and add to negative 6. And the numbers are going to be negative 3 and negative 3, because if you multiply negative 3 times negative 3, you get positive 9. If you add negative 3 and add plus negative 3, you'll get negative 6. So this guy's going to factor into x minus 3 times x minus 3, which I might write as x minus 3 quantity squared, because in the world of circles, which is the world we're living in right now, having a parentheses with a square outside of it and a minus inside of it is a nice form. So that's the technical proper way to do these. There's a shortcut. I can go from this line to that line anyways. I can go from this line to that line real easily. Anytime I'm using the C method, adding a C and factoring, the number that comes up right before I square is going to be the number that winds up in my parentheses that has the exponent of 2 outside of it. If you look at my answer here, the rewrite is x minus 3 squared, and you'll see right there a minus 3 before I got the 9 to add. If you look at this answer here, x plus 4 quantity squared, if you look in that parentheses, right before I got the 16, there's a 4 in the parentheses, and I'm going to get a plus 4. I usually lazy factor. Let me do one or more of these lazy factoring. If I gave you x squared plus 10x plus c and asked you to do the same thing, replace c with a number and then factor it. C is going to be 10 divided by 2 quantity squared, which is going to be 5 squared, which is going to be 25. The number that I'm going to replace with C is 25. And now, rather than thinking about the factoring, anytime I'm using completing the square, after I change the C to the number, the factoring is always going to come out the same way. It's going to be x and then plus this number if it's a positive, quantity squared, minus this number if it's a negative, quantity squared. And of course, living in the world of circles, I don't want pluses in my parentheses. I might write this as x minus negative 5, quantity squared, because a double negative can be turned to a plus can be turned to a double negative. That's supposed to help us quite a bit. So, and the rest of the problems that I'm going to do in this part of the video, they'll probably be a part 3. For problems 9 through 18, if I looked at those equations, they don't look anything like they look like the standard form for a circle. And if I just randomly made up x's squareds, y squareds, and made up an equation, it wouldn't graph to a circle. But I very carefully constructed my equation so that it can be rewritten and it's going to graph to be a circle. So I need to rewrite my equation so that I can identify the center and the radius of the circle and sketch a graph. How do I do this? Step 1 is to isolate the constant, meaning if there's a number without a letter, get it by itself on the right-hand side of the equation. On most of the problems we're going to do, this is already going to be done for me. So to isolate the constant in problem 10, I'm just going to add 4 to both sides. And that's going to give me x squared plus y squared minus 2x plus 4y equals to 4. That's step 1. Most of the problems we're about to do, that step's going to be done. Step 2 is I'm going to group the x's together, and I'm going to group the y's together. Not dealing with a lot of room, so let me just do this up here. Grouping the x's, I'm going to write the x squared minus 2x next to each other, and the plus y squared plus 4y together. I left a little gap for the next step. I'm going to add a first c after the x's and a second c after the y's, and both to the right side to keep my balance. So after the x squared minus 2x, I'm going to add a c, and I'm going to subscript it first c rather than just a generic c because I get two of them. And then after the y's, I'm going to add a c as well, and I'm going to subscript it second c. I'm going to take those c's and add them to the right hand side. If I add the same number to each side of the equation, it can change the appearance of the equation, but it doesn't change the equation. It remains equal. This little dot here is just my pen just slipped. Now I'm going to replace the C1 and C2 with numbers. How do I do the C1? C1 is going to be the number in front of the x to the first power term divided by 2 and then squared. So my C1 is going to be negative 1 squared, which is positive 1. For my C2, I'm going to take the number in front of the y to the first power term, divide it by 2, and then square it. So my C2 is going to be 2 squared, which is 4. So now I can rewrite this as x squared minus 2x plus 1 plus y squared plus 4y plus 4 equals 2. I have a 4 on the right hand side already, and then after the 4 I have to add c1, which is 4, and I have to add c2, which is 4. So isolated the constant, group the x's, group the y's, added c1 after the x's, c2 after the y's, added both to the right hand side. Now I'm going to replace the c1 and the c2 with numbers, and now I'm going to factor, factor, combine. So my next step is going to be lazy factor, combine. So I know exactly how this is going to factor. This is going to factor into x minus 1 quantity squared. I'm going to bring down this plus sign, and this is going to factor into, with that 2, y plus 2 squared. And on the right hand side, 4 plus 1 plus 4 is 9. Let me do a little more rewriting. I'm going to make the y plus 2 squared into y minus negative 2 squared. And the 9, I need to square root it to figure out, I don't have my calculator, I have it on my kitchen table. I was doing math with my nephew. I'm going to square root the 9 and get 3. And so 9 is going to be 3 squared. This is considered rewriting so it's in standard form. So this is the equation of the circle that I was trying to get. And of course, I should know what the center and radius is. The x coordinate of the center is the number after the minus sign in the x parentheses, which is 1. The y coordinate of the center is the number after the minus sign in the y parentheses, which is negative 2. And the radius is the number to the right of the equal sign that's being squared. This is everything other than the graphing that's asked for this problem. And it's really involved. We're going to do a handful of these. Go through these steps over and over again. But let me finish this up by doing the graph. So I'm going to plot the point 1, -2. So go right 1, down -2. And then the radius is 3, so I'm going to go up 3, down 3, right 3, left 3. So this is up 3, down 3, right 3, left 3. And then the best I can, which is not that good, draw a circle. That's everything for problem 9. That's a lot. It's the hardest thing that we do in this chapter, I think, by a lot. But let's repeat it again and again, and eventually it won't be so hard. So, first step in problem 12. Isolate the constant. It's already done. So the first step for most of these rest of the problems are going to be done. I'm going to isolate the number without the letter. And that means to get it by itself on the right-hand side of the equal sign. And that's done. The number without the letter is isolated already. I had to do that first step in problem 10, but I don't have to do it for this because the number without the letter is by itself. Now, I group the x's and I group the y's. So I'm going to write x squared plus 2x plus y squared plus 6y equals 6. And now let me start adding. I'm going to add c1 after the x's. I'm going to add c2 after the y's. And I'm going to add c1 and c2 on the right side. So I'm going to get x squared plus 2x plus c1 plus y squared plus 6y plus c2 equals 6 plus c1 plus c2. Now I need to replace the c's. C1 is going to be 2 divided by 2 squared. It's always the number in front of the first power term divided by 2 and then squared. That's just going to give me 1 squared, which is 1. And C2 is going to be the number in front of the first power term in this second grouping, which is 6, divided by 2 and then squared. It's going to be 3 squared, which is 9. So how am I replacing the c's? Here, I'm going to write this as x squared plus 2x plus c1, which is 1, plus y squared plus 6y plus c2, which is 9, equals to 6 plus 1 plus 9. So done with that step. And now, lazy factor, because I know how it's going to factor and combine. Each time I go to do my factoring, I just look at my C computations. It's going to tell me how to factor. The C1 computation, the number that's in the parentheses with a square is a positive 1, so my x parentheses is going to be x plus 1 quantity squared. In my C2 computation, the number before the 9 that has the exponent of 2 is a positive 3. That parentheses is going to give me a positive 3 inside of it. And then on the right-hand side, I get 16. Let me write this better. I'm going to change my pluses into double minuses. So I'm going to go x minus -1 squared plus y minus -3 squared. And then I need to square root the 16 on this calculator that I just love. Square root of 16 is 4, so that equals to 4 squared. This is my equation. The instructions want me to say what the center is. The center is just going to be pulled off with the numbers after the minus signs. The center is going to be -1, -3. And the radius is the number that's being squared, which is 4. Done with everything except the graph. For the graph, I'm going to plot the point -1, -3, the best I kind of can. Plot the center and go up 4, down 4, right 4, and left 4. So right 4, this is 2, 4, left 4, 2, 4, up 4, 2, 4, down 4, 2, 4. Plot at my center of -1, -3, and now I'm just going left, right, up, and down 4, and that point looks like it was about right there, huh? Sorry about the horrible, horrible graphs, but it is what it is. Few more, and then we'll have to make a part 3 for this video. So, 13 and 14, same strategy, but actually a little bit easier problem. Let me get going. First step is going to be to isolate the number without the letter. And that's already done for me in problem 14. The 21 is already isolated, so I can skip that step and move right on to what's going to be a little bit different. I'm going to group the x's and I'm going to group the y's. There's only one x term, and that's actually good. Actually makes the work less for us. This guy right here, I'm not going to have to do anything to it in terms of a c. I can rewrite this x minus 0 squared. So if you don't have a first power term, you don't have to do anything with the c's. You can rewrite it so you can see the center by putting a -0. X squared and the quantity x minus 0 squared are equal to each other. I'll put this in at the end. I'll just keep the x squared right now, but I could put that in there. So now I'm going to add C1 after the y's and on the right side. But I don't need to add anything after the x's because there isn't an x to the first power term. So I have the problem grouped the best I can group it. And I caught a break here. Because I don't have to do anything with the x's. I can do everything I need with the x's without c's. Now that I have the c set up, I'm going to change the c1 to my number. c1 comes from half of 4 squared, which is going to be 2 squared, which is going to be 4. So I can rewrite this problem as x squared plus y squared plus 4y plus 4 equals 21 plus 4. And now I'm going to factor this. I'm going to combine this. And if I need to, it's optional. If you want, you can rewrite that, but you don't have to. The rewrite on that would be x minus 0 squared to help you see that the x coordinate of the center is 0. This y is going to factor into y plus 2 squared because the positive 2 is in the parentheses before you square. And on the right hand side, 21 plus 4 is 25. So now let me think of this as x minus 0 squared plus y minus -2 squared, changing my positive into a double negative, and then square root 25 to get a 5, and write the right side as 5 squared. So this is my equation. And again, you really don't need the parentheses for the x. You could have left it just a naked x squared, and that would be just fine. For this guy, my center is going to be the point 0, -2, and my radius is going to be 5. So to graph this, I plot the point 0, -2, go up, down, left, and right 5. So here's 2, 4, 5, 2, 4, 5, 2, 4, 5, 2, 4, 5, and then and that's everything for 14. Two more, and then we can maybe one more, and we'll have to go to a part 3. Let's do 15 together, just to knock out one of your homework problems. And I'm not going to get so formal with the steps. I'm just going to do it. So the constants are already isolated. I'm going to group the x's together and the y's together, but there's only a single y, so I don't have to get double c's. I only need to get a c for the x's. So group the x's and the y's. The y's I won't mess with, but the x's I will mess with. And by messing with them, I'm going to add a c1. The y squared, because there isn't a y to the first power, I don't need to do anything to the y's. Now I'm going to figure out what this c1 is by taking the coefficient of the x to the first power term, dividing it by 2, and then squaring it. So my c1 is going to be 9. So I can write this as x squared plus 6x plus 9 plus y squared equals 40 plus 9. Now I'm going to factor. These x's are going to factor perfectly, and the number inside my parentheses is going to be a plus 3. So I can say that's x plus 3, quantity squared. I like sneaking that minus 0 in on this y parentheses because I think it makes it easier to see the center rather than having a naked y like that. And now I'm going to change my double negative to a plus. And I'm going to square root the 49. So the equation of my circle can be written lots of ways, but these are kind of the nice way. So you can just pull off the center. The center to this is going to be negative 3 comma 0. It's the number after the minus sign in each parentheses. And the radius is the number that's being squared, which is the 7. To graph this, I'd plot the point negative 3, 0, go up, down, left, and right 7. So 2, 4, 6, 7 up, 2, 4, 6, 7 down, 1, 3, 5, 7 right, 1, 3, 5, 7 left. And draw something that looks like a circle. That was a little bit fast, but we're buttoned right up to 30 minutes. I don't want the videos to go much longer than that. Really, let me pause this and we'll do a part 3. It won't be that long. Just like 3 problems to do.